Have you ever wondered how big an electron is? It's a question that seems simple on the surface, yet the answer proves to be anything but. Now, you might be picturing an electron as a minute ball, encircled by an electric or magnetic field. And while that's not entirely wrong, it's not the full picture either. You see, an electron is more accurately described as a wavy pattern, one that includes the electric field, rather than being a solid entity. This is our first perspective on the size of an electron. But let's add another layer to this. What happens when an electron is bound to something, like in a hydrogen atom? Well, it spreads out a bit due to the positive charge in the nucleus. This spreading out is explained by a mathematical equation called the Schrödinger equation. So from this perspective, the electron appears larger when it's confined. Now, onto the third perspective. Electrons exhibit a dual behavior. They act as both waves and particles. This is a concept that can be tough to wrap your head around. When observed, they suddenly behave like tiny particles, thanks to something called angular momentum, akin to a spinning motion. So how big is an electron? The answer is, it's incredibly tiny, but also quite puzzling. It can contract or expand depending on its circumstances. And while we can't directly observe its wavy aspects, we infer their presence from experimental behavior. In sum, an electron isn't a static entity with a fixed size. It's a dynamic, elusive, and intriguing part of our universe that we're still striving to understand fully. So the next time you find yourself pondering the size of an electron, remember, it's not just about how big or small it is. It's about how it interacts with its environment, how it behaves under different circumstances, and the fascinating duality it exhibits as both a wave and a particle.